Now we want to discuss about data structure. Very basics. If we say the basics of data structure, definitely before we understand what is a structure, we should understand what is data. Data is basically defined, or it can be considered as raw facts and figures. Raw facts and figures are called data. And when these raw facts and figures are processed, we get information, right? The end users of user of computers are basically interested in information. They are not interested in data, or they are not interested in raw facts and figures. But just let me finish it. So data means raw facts and figures, and end users who uses computer, they are mainly interested, they are laymen, and they want to use the benefits of computer or any processing. That's why they are interested in information. But as a computer engineer, we should be interested in both the information as data and data. Information means, because we are, as engineers, we are supposed to process it. And also we should keep in mind how the data is being presented after processing to the end user. Then only this will be accepted. Then only your output or your work or your program or software will be accepted by end users. Our main target is to satisfy end users, and this end user satisfaction, that is called the extent to which the end user is satisfied is called quality of services, or QoS. O in small letter, Q and S are in capital letter, QoS. And QoS is the primary concern of a programmer. Okay, primary concern of the programmer. That's why it is our responsibility is to manage data. And it is also our responsibility to present data. Present data means data after processing. Whatever we will get, that means the information to be presented to the end user. Both are the functionality of the responsibility, in fact, of the programmer. And apart from that, the way we process it, for example, take a very small example. You are very, not you, say your friend is very hungry. And he want to, or he or she, whoever, he or she wants to eat rice plus dal plus some kind of sabzi or something, right? This, for example, suppose that you wanted to prepare rice, right? What you will do now, he is the end user. He or she is the end user. First of all, you are the person, say you are the cook in the house, because you want to satisfy your friend. How do you want to satisfy your friend? By giving a good tasty food, and that will decide the quality of service that you are providing to him or her. Now the question is, if you want to prepare rice raw rice I am talking about. Rice means cooked rice. Okay, first of all, take this one as a information. So information is, your information is cooked rice. Cooked rice. Cooked rice is the information. This is information. And the you need some raw rice, raw. Then you need water. Maybe you need some ghee or something to prepare good quality cooked rice. So these are called, these raw materials, this is called data. And we will take this data in a container, we'll put all like here, and what we will do, we will cook it. We'll cook it. And this cooking process, this entire cooking is called the processing of your raw data. Processing. You are processing the raw rice mixed with water and ghee. And then this process will take some time, say 15 minutes, depending upon the process that you are using. Now this process, actually, you may use one electric oven, you may use one LPG gas, you may use some wood fire, you may some use other method. So each of them are contributing to the process, but in a separately. These are either we will be using any one of these process to do this, to cook the raw rice, or to process the raw rice in order to form cooked rice. Now, for every different methods, your taste will be different. Every ingredients you put in the rice while cooking, your taste will be different. Now, the end user will be satisfied only when the quality or the taste of the rice that you have prepared is above certain QoS level. Now, this process, entire process of cooking food, you can consider it as a processing. Cooked food is the information, and the rice, water, and all these things are called the data. And this is called a program, or this is called the processing steps. So these are the steps that you are using to process, right? These are very few steps. For example, the first step is put water, rice, ghee together. Then number 2, take it in a container, for example. Then number 3 is put it in a gas, or microwave oven. Then after that, fourth one is you must have to switch on the microwave oven, right? So these are the steps to be followed, and these steps to be followed is nothing but your algorithm. This is the algorithm to prepare or to convert the raw rice, water, and ghee into a cooked rice. Here, this is data, this is information, and this is the program that you are applying in order to convert data into information, right? So that is about the data and its processing. But again, I have not answered the question, what is data structure? It will only solve the problem of what is data and why do we use it, right? And also it will tell what is a process, maybe, but I have never said you, or in my discussion, I have never covered what is data structure. But our main concern is to understand what is data structure and why do we need it. Okay? Okay. So in computer programming or any computing device, there is a basic block diagram that which is given as this one. This is processor or processing. This is output. This is input. This is the most fundamental and basic block diagram of computing, right? This is the most fundamental block diagram of computing. So what this it says that you have to give input to a computing device, then this computing device will process your input and it will produce output, and this input is nothing but the data and output is nothing but your information. As said earlier, end user is interested in only information, and as a computer engineer you need to talk about both data and information along with the processing. End user is not interested to know how much effort you are putting in order to write the program, in order to analyze the data or process the data. He's only interested how much he is satisfied, the extent up to which he is satisfied. He is interested only the quality of services. That's why you might have noticed that few applications that we use in our mobile phone, we do not prefer to use those applications. But it does not mean that the end user, I mean the programmer or the designer of this application has never put his effort in order to prepare that application. But although he put effort in order to write down this application, sorry, since the quality or end user is not satisfied, that's why this application is, nobody is going to use that application. So what we are supposed to do, we need to take care of quality of services always in our mind while designing any program or while designing any application. So that is the main interest, main things to be remembered, that whenever we write down a program, it means it will take some input and it will give some output. Input is data and output is the information. And we want quality of services in terms of fast execution, in terms of relevant data or information retrieval, or in terms of some space requirement. That means your program should process the data, means program should give the output immediately in a fraction of a second. Similarly, the information which I want, I need to get exactly that information. Irrelevant informations are not for use to the end user. Moreover, the space required to store the data as well as your program should be very minimum. Then only user will be satisfied from your quality of service, right? So that is the way that process the data. But here also, what is data structure? Again, the question remains same. What is data structure then? What is data structure? Data structure, we have understood what is data. In real life we have understood, in programming we have understood, but what is data structure again? Now question here again, it derives to another concept. When we, let us now come to the computer programming. Suppose that I want to, my problem is add, very small, simple, add, write a program to add two numbers, right? Or let us suppose that, let us not consider a computer program. Suppose I wanted to tell you, I'm giving you one question to solve. Say add two numbers. if I say add two numbers, then if I say 5 and 6, immediately you will tell 11. You can tell 11. If I say 15 multiplied by 2, you will say 13. Immediately you can tell. But if to add two numbers, we need to remember. We need to remember. Unless we remember, we won't be able to add this. 5 and 6, yes, we can remember. If it is a big number, very big number, I can add whatever the number, 20 digits, 30 digits, only adding I can do manually. I'm not talking this page or where I am writing this number. This is kind of secondary storage, and whatever I remember, that is your primary storage. Although I write down 162319 123141, although I am writing it, but while we add 9 plus 1, you just think 9 plus 1 we keep somewhere in our brain and we add the result 11. We keep 1 here. 9 plus 1 is 10. We keep 0. We have in our daily life also, we use two kind of memories. One is that we remember in our brain cells, which is called our memory. And another one, we keep it in the paper. So this is the one that I remember in our brain. It is actually the main memory or primary memory, main or primary. And that we keep it here, this is called secondary. Or it is actually our hard disk or something, where the CPU, the construction of CPU, block diagram of CPU, if you remember, there is one device which is called ALU. You might have studied in your first semester course, ALU, arithmetic and logic unit. And also, yes, you remember, you have registers. You have registers R1, R2, R3. And there is one very special register which is called program counter. You remember that? ALU, there are two input lines, input 1 and input 2. Input 1 and input 2. And there are some control signals, because this is hardwired control. And for every operation, there is one line, add, multiplication, and there is one line output through which we get the output. And this output, now this input and input 2, if I wanted to add 5 plus 6 plus 7, computer also what it does, it adds only 5 and 6. Then keep the data in the temporary register R0, R1. Then the second one, it keeps this one here, and the next result, previous result 11 here, and it gives 18 like this. This is the process, arithmetic and logical unit, right? And whatever we do, we must have to bring to this ALU, and it is called the ALU control unit. ALU, this is like this, and all together this is called central processing unit. We have input unit, we have output unit, like this. This is called basic block diagram of a computer or computing device, and this is input unit. So the function of the input unit to provide data to the ALU. Okay, so here what happens here, input will give the data, that data will go to the main memory, and this one will have some signals, two input lines, output lines, and this output device, actually it will give it output to the outside world. But before we process, we keep it in the main data, we keep it in the main memory, and from main memory data will go to the ALU, and result will also come back. That means first data, we will insert data, it will be stored in the main memory, it will go to the ALU, it will add it, again the result will come, and result will be given to the output unit only from the main memory. We cannot do directly compute and put it to the output device. It's not going to happen. We must have to keep the data in the main memory before it processing or before we process the data. This is the main memory. And we are not talking about the secondary memory. We are talking about only about the main memory, where we store data before its processing. So this main memory actually holds both input and output. Input and output means the data that we process, and input means the data we supply, right? Now the question again here comes, this is data, we understood that we store data in main memory, that is fine, everything is fine. But what is data structure? Suppose that I wanted to arrange, the operating system will allot a specific space for you to use your program. This is your user program. Now it is your responsibility to how do you organize your huge data in main memory. This is main memory, but on the very small area which is called code segment and data segment, this part, only this portion is allocated to you, but you have a huge data. And first of all, within this small location that is allocated to user program 1, you have to manage the data. How do you manage? How efficiently you can manage your data in main memory is known as the concept of data structures, right? So data structure, now if I say that I am studying data structure, it means that I am studying about how to manage data efficiently in the main memory during the execution of the program. That is data structure. But again, one more question arises. Why need to structure the data? Okay? What do you mean? Why do you need to efficiently manage the data inside the main memory? Unorganized storeroom, for example, and also just to see one, I wanted to see very well organized here. I think this one, let's say this one. Now to perform a task, either you have to search an item in this store or you have to search an item in this store. It will take very less time to search an item here. You start from here, go around, and you will find, because if it is do not find, that means it's not there. But if it is here, then it is pathetic altogether. It will take more time to search more. So from time complexity point of view, data management is efficient here, faster here, and this is very slow here. Suppose you have ordered a new item which is not actually available in the store, right? It is not available in the store, and you want to place it somewhere inside the store, right? This is one situation. Second one is yet you have a new item and you want to you put it here, you want to keep it here, right? If you consider these two situations, then definitely while keeping the things, while we store the data, we have to think once, maybe these all items are organized in a alphabetical order, starting from item, starting with A, B, C, D, that way. If this is the case, then if you want to store a new item in between, what you need to do? You need to shift the place. You have to find place for this, isn't it? So while storing the data or while storing the item here, it will take more time. But while searching, it will not take more time. But on the other way here, if you want to store the data, you put the data, new data here, put it anywhere. When it is coming for searching, it is really very difficult task. Now, when we consider again, why I am telling this one to you, because I'm talking about the organized data structure or organized data, which is called data structure. Organized data implies that we need to store the data inside the main memory very systematic way, store data in a structured way. But I'm claiming that if it is stored in a structured way, then we can search the item, that is searching time is very less. If searching time is less, that is very good. But when we'll bring data to the main memory or to the store, we have to somewhere keep it. We have to keep it somewhere. That is called, this is adding data. Adding data, or we can say organizing data. Organizing data. So if it is the case, although searching takes very, very less time, say in fraction of milliseconds, but when I wanted to store the data, it takes long time. On the other case, if it is not structured, unstructured storage, while searching, it takes lot of time. But if it is storing, that it's very less time. But ultimately, total time remains same, almost same. Then what is the benefit? If you consider, is there any guarantee that you will find the item here? If you do not find, you will end up with the conclusion or with the impression that this item is not available in the store. But can someone guarantee that it is not there? No, no. Although advantages are there for both structured and unstructured organization of data, but we prefer only structured organization of data. That means or structured data. Why? Because if we do not find the item here, that is okay. If I do not find the item here, that means 100% sure that item is not there. If I do not find the item here, it does not mean that item is not here. That means it is called, if you do not find the item, that means called it is negative, right? Negative. If we find the data, it is called positive. Here, false negative, the rate of false negative is very, very high. But on the other hand, here, rate of false negative, here, in case of here, rate of false negative is false negative is almost zero. Rate of false negative is false negative means not found. False negative is almost equals to 0. So that is the reason we prefer, let it be more time consuming while storing the data, but still I want to organize data so that the accessing of data at the time of processing is less and rate of false negative is almost 0.